right, welcome everybody. So I'm very excited for our lunch today. Really great. I want to give my thanks to the staff and to PCM for setting up a really terrific event here. And so basically what we're going to do is continue to have lunch. The buffet stays, so you can grab more beignets if you like, or whatever else. But we're going to give out our Display Industry Awards, and then we have a really terrific lunch speaker who will speak afterwards. And then we'll go from there. So with that, I want to start by really thanking the hard work of the Display Industry Awards Committee. This is a prestigious award which is difficult to give out with so many possible awardees and so many excellent awardees. So I just want to start by thanking Wei Chen and Steve Atwood, who co-chaired the committee. And so Steve Atwood is going to come up on the stage, explain the award a little bit, and then also give out our very first award.
Didn't know which way you were going. Thank you, everyone. Each year, the Society for Information Display recognizes the best displays, components, and applications that are introduced to the market during the previous calendar year with our Display Industry Awards. As one of the industry's most prestigious honors, the DIAs highlight innovations that advance the state-of-the-art in display technology. And the DIA committee selects the winners each year based on the nominations from across the industry. I can tell you that it was a especially difficult year this year because there were so many great nominations and so much wonderful innovation in our industry. And so these are highly deserving recipients this year. In the first category for display components of the year, I'll introduce Pixeligent for their PixCore High Refractive Index nanocomposite materials for XR displays. And we're going to see a short video from them.
The promise of extended reality has been building for over a decade. The drumbeat began when Google debuted its novel Google Glass in 2013. Fast forward 11 years, and we finally have the right combination of design, advanced materials, hardware, and software. At long last, the future of extended reality is here. Pixeligent has helped drive extended reality forward with core technology focused on delivering advanced materials that enable extended reality device manufacturers to match their vision. Our proprietary method of synthesizing, capping, and mass-producing nanocrystal metal oxides results in unmatched control over particle size, shape, and surface chemistry, enabling us to deliver films with transparencies greater than 95% and haze of less than 0.1%. Our PixNil formulation leads the market with the highest refractive index, greatest stability, and the widest process windows available for patterning waveguides in extended reality devices and diffractive optics. Why does this matter? Well, since waveguides essentially produce the images that materialize on the device screen, it's imperative that the material properties deliver the best image quality and highest device efficiency. That's what our formulations do. On top of enabling properties, our products are valued for their versatility. Compatible with glass and plastic substrates, they can be applied for nano-imprint lithography with no need for adhesion layers, producing films that are thin and uniform at a much lower cost. Our comprehensive line of products for extended reality designers includes our 2.0 refractive index PixClear titanium material to maximize field of view, UV-stable products that utilize our PixClear zirconia, and our recently introduced PixCore formulations that deliver the highest combination of a refractive index over 1.8 and UV stability. Every PixNil product delivers a uniform refractive index throughout the structure, ensuring optimum performance of customers' unique waveguides. Our customers value Pixeligent's ability to fine-tune all critical properties of high-index formulations, addressing their specific application needs in ways that competitors simply can't match. That's why leading consumer electronics companies are turning to Pixeligent for their extended reality device designs. We're proud to be their partner of choice to deliver on the promise of extended reality.
Okay. And now that we know a little more about their wonderful technology, let me invite to the stage Craig Bandis and Neil Shearer to accept the award. And now to introduce the rest of the awards, I'm going to invite our committee member, Shri Paravemba, to the stage. Thanks for doing that.
Okay. Thank you very much. So the next award is the 2024 Display Component of the Year Award, and the winner is Celid. Let's play the video, please.
Hi, we are Seik. Seik is a Japanese startup company refining our technology to provide value to customers in the AR industry. Our core technology is waveguide. Seik started as a special recognition software company, but in 2020, we started waveguide development.
To make AR glasses as stylish as normal eyeglasses, we believe waveguide are essential components due to their optical performance, manufacturability, and also design aesthetics. Our waveguide is transparent without any extra patterns and even thinner than a penny. One of the strengths of Select is the in-house developed simulation technology. It allows us to release new version of waveguide quickly within short cycle. This is our full-color plastic waveguide. Plastic T1, which won the Display Component of the Year, maintains high optical performance despite being made of plastic. Also, we are building a production ecosystem for mass production with our partners. Actually, the new version after Plastic G1 achieves even better performance. Please come to experience our latest innovation.
The journey of Seik is far from over. Please stay tuned for the next evolution of Seik waveguide.
Very nice video. Accepting the award for Celid are Shiraga-san and Mitsui-san. Please come up on stage. So much. Shiraga-san, Mitsui-san. We'll go here, so it's easier probably for the photographer. This is yours, by the way.
Thank you.
Yeah, you need to take it back. You can just, I'll stand in the middle. You're taller than I. You need to stand here. Yeah. Yeah, there you go. Very good.
Thank you so much.
Good job. I had a chance to see the product yesterday, and sometimes the video is amazing, but the product also is very amazing. You should go take a look. The next award is the 2024 Display Application of the Year Award. And it goes to Flanders Scientific. Let's play the video.
The XMP550 is a 55-inch QD-OLED reference display specifically designed for the HDR and SDR content creation market. It signifies a paradigm shift in professional post-production as the first large-format UHD HDR display to match or surpass the performance typically only seen in 32-inch and smaller mastering monitors. With the XMP550, post-production facilities now have new possibilities for room design, including building rooms with a single display that serves as both the colorist's reference monitor and the large format monitor for clients. Simply being large is not enough for a display to qualify as an appropriate single monitor reference solution for post-production. The display must also be sufficiently bright for HDR mastering, truly RGB additive for white without any color volume collapse, and feature exceptional off-axis viewing to ensure that both clients and the colorist are viewing the same image. The remarkable QD-OLED panel used in the XMP550, supplied by our partners at Samsung Display, rises to all these challenges with truly unparalleled performance. The exceptional panel performance of the XMP550 is enhanced by professional connectivity and an industry-leading color management system featuring our Gaia Color Direct Connect volumetric AutoCal feature. This system enables you to connect a probe directly into the monitor to run a completely automated calibration routine, not just for one color space selection, but for any combination of color management options available on the monitor, all from a single calibration run. This allows thousands of unique color management options to be accessed from the data stored in the monitor's non-volatile memory during the last AutoCal run, greatly simplifying access to accurate calibration for everyone in the professional post-production market. The XMP550, along with its recently released smaller and larger variants, is making high-quality reference monitoring accessible to more users across more form factors than ever before. Learn more at flandersscientific.com.
The award was for the XMP550, and I have a feeling once you see this in real life, you will want to change your TV. This thing is so good. Maybe a little bit more pricey, but so good. Accepting the award on behalf of Flanders Scientific are Brian Gordon and Bram Desmet. These are heavy, aren't they? Thank you very much. Thank you. Thank you. This time I will actually give you the award. And we should probably stand here so it's easier for the photographer.
Great. Thank you so much.
Very good. Good job, guys. Next slide, please. Okay, perfect. Oh, can we go back? Excellent. The 2024 Display Application of the Year award goes to Seventh Sense for the sophisticated, oh, you moved too fast. Can you go back to that slide? Yep. I can speak fast, but not that fast. For their sophisticated management control and pixel processing system in the Sphere internal LED display installation. For those of you that have been in Vegas recently, you see not just the exterior, but interior of the Sphere. It's one of the largest displays in the world. What an amazing product, an amazing experience, and well deserved. Let's play the video, please.
Of the scale of a project like Sphere?
Is ginormous a technical term? I mean, it's just like, you've probably seen images on social media, but you just can't understand or really get a real sense of scale through a phone. It's just a massive, massive, giant display that, with the right content, you're taken away to a completely different world.
The graphics at the MSG Sphere in Las Vegas are on a scale that the world has never seen before. Processing 16K uncompressed video requires powerful technology. So we're talking to Brian Hinckley and Rich Brown from Seventh Sense about their work on the project.
MSG's vision was an IP-based infrastructure for the whole Sphere, which was, very future-looking. That vision drove a whole raft of innovation in our business. All of our product range needed to change to really be able to accommodate what MSG plans to do in the venue. At a top level, what we've got is a pipeline from a media server platform. The output of that system goes through a big IP network, 2110 IP network, into our Juggler pixel processor. That pixel processor is an FPGA-based solution. It takes in the inputs that are needed into the system, the cameras, the media servers, generative engines, that kind of thing in the future, and allows us to composite and, basically pack and produce the media into the correct areas of the display. One of the key things I'd say about Sphere is the quality and the investment in doing everything to the highest possible standard. It's been driven that way from start to end. So every device in the network is running at a quality that I've not seen on many other systems ever. The amount of data we have to stream reliably to be able to play a show is absolutely incredible.
What an amazing product. I bet, in the past in Vegas, the attraction was a certain casino, a certain new game, there's some show and so on and so forth, or CES. Actually, this time at CES, I took a bunch of pictures of all kinds of display technologies and posted it, but invariably the question was, did you go see the Sphere? That's how much interest there is. Good job, guys. Accepting the award for Seventh Sense is Eric Nolfo. Good job.
Thank you so much.
This is yours.
Thank you so much.
You need to stand sort of like right here. This is the line that separates us. Yep, right there.
Thank you so much.
Thank you.
Have a great day.
The 2024 Display of the Year award goes to E-Ink for its E-Ink Spectra 6 full-color reflective display. Let's play the video, please.
Well known as the screen technology found in your e-readers, but we are also a leader in retail displays like electronic shelf labels. We recently made a big splash with BMW, wrapping their cars in our film materials. E-Ink has been working to bring full color to our reflective displays for a number of years. We started with spot color for retail signage, and since then have launched color e-readers, color signage, and color changing surfaces. Hi, I'm Brian Chan, Senior Director in charge of Business Development and Applications Engineering. For years, I have worked closely with our research team in Fremont, Billerica, and Taiwan on the development of Spectra, first from 3-color displays, and now our full-color platform. Last year, we announced E-Ink Spectra 6, a full-color, vibrant display capable of producing images with a gamut volume over 60,000. E-Ink Spectra 6 provides near-print quality for the replacement of any paper sign, including point-of-purchase displays, signage, posters, and other in-store advertising. E-Ink has worked with our retail partners for years to understand their market demands. We've taken all their feedback into consideration when we designed our next-generation product. E-Ink Spectra 6 has been designed to bring a full-color experience to our retail partners, allowing them to dynamically convey their messaging while using the most power-efficient display on the market. Digital out-of-home signage, with its need to display advertising and informational messaging, has been an area our customers have been keen to expand into. Learn more about E-Ink Spectra 6 at our website, www.eink.com, or reach out to our sales team to see how we can help you.
I had the privilege of working for E-Ink many years ago, and I would travel all around the world, talk about their monochrome product as to how wonderful that was, and it's so glad to see the development of color displays. Accepting the award for E-Ink are Edzer Hoytema and Hongmei Zhang. Make sure my fingerprints are not on. I might as well go and stand here. Edgar, think this like a red carpet. Good job. Congratulations. You need to stand on this side. Yeah. And I'm going to give this to Hong Mei because I like her better than you.
Perfect.
Yeah. You don't have to share with him. All right, cool. Thank you.
Thank you.
Thank you. Good job. The 2024 display of the second display of the year award goes to Apple for the micro OLED display and the lens system used in the Vision Pro.
Creating our first spatial computer required invention across nearly every facet of the system. Apple Vision Pro needed to deliver huge amounts of compute performance in a compact wearable form factor. It needed an advanced real-time sensor system as well as incredibly convincing spatial audio. And of course, technological breakthroughs in displays. Your eyes see the world with incredible resolution and color fidelity. To give your eyes what they need, we had to invent a display system with a huge number of pixels, but in a small form factor. A display where the pixels would disappear, creating a smooth, continuous image. It starts with a micro OLED Apple Silicon backplane that fits 64 pixels in the space of a single iPhone pixel. They're just 7.5 microns wide. Combined, Vision Pro has 23 million pixels across 2 panels that are each just the size of a postage stamp. That's more pixels than a 4K TV for each eye. To magnify these panels and wrap them around you, a sophisticated lens solution was needed. We designed a custom 3-element lens with incredible sharpness and clarity. The result is a display that's everywhere you look, delivering jaw-dropping experiences that are simply not possible with any other device. It enables video to be rendered at true 4K resolution with wide color and high dynamic range, all at massive scale. And fine text looks super sharp from any angle. This is critical for browsing the web, reading messages, and writing emails.
What's interesting I find about products like this are, it's not just that the guys who designed the product have to answer to Wei Chen and that kind of thing, but also there's a whole industry waiting to see how this product will do so that therefore they can raise funds, they can develop this and so on and so forth. The expectations on this team is pretty tremendous. So accepting the award for Apple are Alexander Lavender and Robin Huang. Congratulations.
Thank you.
Good job. This is yours. Okay. Just stand. Oh, careful. You stand here. Okay, excellent.
Okay.
Thank you, guys. Good job. I should have asked them what's the next product. Then I'll have to help them find new jobs. One of the other very important things that SID does, and it started a few years ago with the iZone, or the Innovation Zone, and this is to encourage smaller companies to participate, have the opportunity to meet decision makers from virtually every major display company in the world and many OEMs and so on. We started the iZone, and this has been a tremendous success. Many companies have benefited. Many of them come back and exhibit, many of them being able to showcase their technology and make further progress in their for their companies. So the iZone committee picked the winners from this year's iZone exhibits. And before I announce the winners, I would like to request the iZone committee to kindly stand up and be recognized. Good job, guys. I want to particularly thank Norbert Fruhoff and Anup Menon, who are the co-chairs of the iZone, for all the hard work. So the awards have already been presented, so you don't need to come up. I'll just ask the winners to stand up and be recognized. The Best Prototype Award winner is Yongzhang Laboratory. Members, representatives, please stand up and be recognized. Good job, guys. We are hoping that in the future you will have the largest booth. Right? You said yes, right? Okay. We'll remember this. And we also recognize, the iZone also recognized 3 other companies as honorary companies that exhibited some amazing products. So the committee was saying it was a very difficult challenge for them to find the best of many innovative technologies, but they recognized 3 different companies, and I'll request the representatives of these companies to also stand up and be recognized. L-Star. There they are. Good job, guys. Looking Glass. There they are. Q-Pixel. That's the end of our awards presentation. It's my pleasure to invite Nikhil Balram, keynote chair for this year, to come on stage. Hello.
After hearing Shri, I realized that the job entails more than I thought. I thought it was just about making announcements. Apparently, stand-up comedy is also part of it. So in that vein, I'll share a secret with some of you who, if any of you are here for SID for the first time, if you ever wonder who is the most important person at SID, I'll give you a tip. Count the ribbons. So, like many of you, I always thought of quantum dots as this amazing ingredient that was made for the display industry, that its main purpose was to make us all successful and rich. And then a few months ago, I met someone who you'll be hearing from soon, Olga Alexopoulou. And it just blew my mind what she was doing, the things that she was doing, this idea of using quantum dots across this range of applications through pigments was just jaw-dropping. So I thought this would be a truly amazing addition to this week when we've been celebrating so many aspects of quantum dots. So it gives me great pleasure to introduce her. I'll just go through her bio very briefly. We'll have the talk and then we'll do some Q&A. There's enough time. There's some Q&A. There's a mic there, so you'll be able to come up and ask your questions. So Olga is a painter, and her work has been exhibited in galleries and museums from Tokyo to New York. She was born in Athens and studied at the Ruskin School of Art at Oxford University. In 2018, she created a new pigment called Quantum Blue with a small team of scientists from at Berkeley Lab in California. Now she's head of color and co-founder at Quantum Light, the only company in the world that specializes in quantum pigments. Please join me in welcoming Olga.
If I were to ask you, which are the most important powders in your life, what would you say? Some of you, especially after a delicious lunch, would probably think of coffee. Some of you of sugar. Others would think of life-sustaining powders called medicine. However, there is one category of powders that is intrinsic to the human experience that people completely take for granted. These powders were invented before humans could even grasp the concept of how to build a roof above their heads or how agriculture works. But we know that humans have been passionate about creating these powders for at least 64,000 years. What are they? If we could change the slide. Pigments. These powders have helped humans leave a trace of their existence to survive for eternity, knowing that they themselves wouldn't. They have helped people express their dreams, their desires, their fears, and create whole universes from their imagination. Maybe if I could get a little beepy thing, or change the slide otherwise. Great. Our cave-dwelling ancestors found rocks lying around nearby, ground them up, and probably using pulverized amber as a binder, they created a pigment they could spray and leave their handprints as a mark for posterity. Next slide. Over the thousands of years of human history, people have gone to extremes to create pigments, like making pigments from dead people. Introducing caput mortuum, a pigment made from flesh of mummified bodies that was popular all the way until the mid-20th century. Here we see a painting by one of the most prominent Victorian painters, Sir Lawrence Alma-Tadema, who used this brown pigment excessively for its warm and translucent qualities. The pigment, also known as mummy brown, was made by ground-up mummies from Egypt, and apparently it didn't matter whether the bodies came from men, women, or children. As the trade took off all over Europe, dealers of the prized brown started using freshly executed prisoners whose bodies would be treated with bitumen and then exposed to the sun before being ground up to create the pigment. Horror and beauty cohabit in this work of art. Some years ago, I had a solo show at the Heraklidon Museum in Athens, Greece, and the museum designed some workshops for children to complement my exhibition. The workshops were meant to give kids an idea of how paint works. So they started a workshop led by University of West Attica lecturer Maria Hatzidakis by showing a photo of this bug to the kids and asking them, would you eat this? Of course, all the kids said no. And then the workshop teacher asked, have you ever had a red lollipop? To which the answer was, of course, yes. Well, I have news for you. The cochineal bug is a current global staple of the food industry when it comes to making products look red. So the truth is that most of us have been consuming it for years. It is added in juices, yogurts, ice creams, candy, soft drinks, by some of the most recognizable drinks of today. It is also the go-to red for the world of cosmetics for lipsticks. So the lips of the girl with the pearl earring were also painted with cochineal red. How did the bugs end up on Vermeer's most recognizable portrait? The female cochineal insect that you see in the photo were first used as early as 700 BC by South American civilizations for their stable red. The immobile insect is brushed off the cacti it lives on, then boiled, left in the sun, and processed until the red powder is extracted. The Aztecs used it extensively, and after the Spanish conquest, its trade became intertwined with slavery as it was imported to Europe. Today, you can find it very often by looking at the word carmine or natural red number 4 on everyday products on the labels in supermarkets. Luckily, the history of pigments has not always been this harrowing. The Renaissance owes its brilliance to a pigment called ultramarine blue. The name comes from Latin, meaning beyond the seas, ultra and mare, as it was mined in the ancient quarries of Sare-Sang in Afghanistan. The mining of lapis lazuli, which is a stone that ultramarine comes from, begins as early as the 7th millennium BC, which is contemporary to the first cave painting I showed you. The stone is used in antiquity as a pigment, but reaches its height during the Renaissance. It's not easy to convey just how important ultramarine has been for the history of art, or just how precious it was, as it was even as expensive as gold. Ultramarine blue was so highly prized, and its production took so long, as it had to be carefully ground up and purified, that it was reserved only for the most important parts of a painting. Often, artists kept the minuscule amounts that their patrons had procured for them hidden away, and only at the final stage of the painting would they use it for the prestigious parts, like the Virgin Mary's robes, and even then, only for the final top layer of the blue. As a painter, I have spent years studying the color blue from antiquity to today, often traveling around the world to explore rare blue pigments, from rural China and the capital of porcelain in Jingdezhen to top research institutions in the US. There was one blue that intrigued me, that of the blue hour. It took an army of 19th and 20th century scientists to explain the eerie and almost fluorescent blue color the sky takes on during the blue hour, which is the brief twilight after sunset and just before sunrise. As the sun slips below the horizon, the sky lights up an intense blue for about 30 minutes before fading out as night falls. The British Lord Rayleigh proved that the scattering of light generally makes the sky blue, but more specifically, the physicist Edward Orson Halbert was the first to understand that specifically during the blue hour, the blue is more intense thanks to a phenomenon recorded by the Frenchman James Chapois while studying the angle from which the remaining rays of the sun strike the ozone layer, the Chapois effect. And finally, our own eyes, as they make the transition of how we see night, myopic vision before night vision, registering the blue as brighter, the Purkinje effect. But how could one distill this particular and very intense blue of the blue hour into a bottle to use as a pigment on a painter's palette? In August 2018, I landed in California to see if my theory that the blue hour could be turned to a pigment with the help of nanotechnology could become a reality. I remember that summer morning as I stopped at the foot of Berkeley Hills and looked up at the top, which was shrouded in a thick mist. Behind the haze loomed the famous Lawrence Berkeley National Laboratory, where some of the world's most important scientific discoveries had been made. The whole project has started a year and a half earlier under the auspices of Professor Paul Alivizatos, one of the most internationally recognized nanotechnology scientists. What was my idea? That I could harness the incredible optical properties of the particles called quantum dots to create a new type of pigment. Quantum dots, which most of you know from the display industry, are small particles of crystalline semiconductors and constitute a new class of materials. They are very pure in color, and despite their amazing optical properties, they had never been used to form an artist pigment. Quantum dots, due to their size, lie between classical physics and quantum mechanics, and thus exhibit the phenomenon of quantum confinement. Due to the pressure of this phenomenon, the light, and consequently the color they emit, is more intense than conventional pigments. Inside the the underground laboratory, deep beneath the Earth's surface, at the end of our trials, I remember picking up a small vial and looking into it. The blue hour had been distilled into a small bottle, and quantum blue was now a reality. Fast forward a few years, and we are now an Oxford University-affiliated startup called Quantum Light, which is dedicated to bringing Nobel Prize award technology to the world of colors, pigments, and dyes. Today, at Quantum Light, we are harnessing the extraordinary power of quantum confinement to create the pigments of the future, quantum pigments. Along with Jason Hartlove, who most of you know as the co-founder of Quantum Light, and also former CEO of Nanosys, and current Vice President of Display and Optics at Meta, we have created a small team of some of the most brilliant minds in the field of quantum dots and pigments. This past October, the extraordinary scientists Alex Akimov, Louis Bruce, and Mungi Bawendi were awarded the Nobel Prize for inventing and developing quantum dots. For me, one of the most fascinating moments from their journey was about 4 decades ago when Louis Bruce noticed that the sample he had left on a lab bench was changing color in a strange way, which made him think that he was witnessing quantum physics at play. In the middle, we see a photo of an original sample from Alexei Akimov's experiments of quantum dots in a glass matrix, because he started his journey by trying to understand the color in the art of stained glass windows. This eventually led to the invention of quantum dots, and in turn, on your right, a photo of quantum red, one of our first quantum pigments. Because of all this, quantum pigments will have phenomenal optical qualities. Firstly, for the first time, we are manipulating light to create pigments never seen before. To quote my co-founder, Jason Hartlove, we will be painting with light. With conventional pigments, if you mix red and green, you get brown. With quantum pigments, because they follow the way light is mixed, which is additive, when you mix red and green, you get yellow. Even this small fact is revolutionary for an artist's palette. Secondly, being able to emit light at any specific wavelength in the visible spectrum. The size of the quantum dots determines its wavelength, and thus color output. The smaller the dot, the more intense, and hence the blue light is emitted. The bigger the dot, the redder the light is emitted. Quantum dots can be engineered to emit at any chosen nanometer on the spectrum of light. This goes for the visible but also invisible part of the spectrum. Thirdly, being significantly brighter than conventional pigments. And fourthly, being illuminant independent, as I will explain in the next slide, is because of quantum confinement. This very simple diagram is actually the most important one in my presentation, because it actually explains what happens when we utilize quantum confinement in pigments. Conventional red pigments absorb light and reflect only the red part of the spectrum. Quantum pigments absorb and then emit the whole spectrum, but convert it into a specific chosen red color, down to the nanometer. This makes them not only significantly brighter, but also it means that the color does not change depending on the environment's illuminant. What does that mean in practice? Imagine that you have a car painted with blue conventional pigments, and you park it at night in an underground parking lot. Usually the parking lots have orange lights, which means that when you will be looking for your blue car, it will appear green. Whereas if it was painted with quantum blue, it would always appear blue, because it would always be emitting at the chosen wavelength, and you wouldn't lose your car. All these unique optical qualities make quantum pigments the next chapter in the history of pigments. So this brings us to the question, where can quantum pigments be used? And the answer is pretty much everywhere. Art, architecture, plastics, apparel, automotive. One of our scientists said, if we ever created hair dye with quantum pigments, it would look like CGI characters walking around the streets. What about the environmental facts? The production of an average kilo of conventional pigment produces approximately 10 kilos of waste, which is mostly discarded in countries like India and China. And if we think about the textile industry, well, it uses 1.3 trillion gallons of water to dye garments, enough to fill 2 million Olympic-sized swimming pools. Most of this water, loaded with harmful chemicals and dyes, flows untreated into rivers and streams. whereas our quantum dots are produced in a net zero factory where the little water that is used is continuously recycled on the premises. When we think of quantum pigments, we think of the colors we already know, but brighter and consistent. However, there is more. For example, our team is developing quantum black, a super black with a red glow. This new super black is achieved by especially formulated quantum dots that take light and emit it back in the non-visible part of the spectrum, and only leave a tail of emission in the red. This creates a very intense black with a mysterious red glow, as you can see on the sample on your right. There are loads of pigments like that that are waiting to be discovered. To quote the Nobel Committee, quantum dots open up a third dimension in the periodic table. Pigments that create a play between the visible, the invisible, and with tail ends in all sorts of colors. And we're only just beginning. Thank you very much.
So we're now open for questions. Please stand up. Please step up to one of the mics and ask your question. And while you're doing that, I'll get the ball rolling. Is it true that you're now raising money?
Yes. But so we're actually completing a round. So if anyone is interested, let me know, because the round is closing in about 2 weeks. So hurry up if you're interested. Yeah. Thank you.
Question, please go ahead. Is the mic active?
Yes, it is. I'm interested in how you effectively communicate between someone with your background and the technologists and engineers and so on. What are the difficulties and what are the techniques you use to really make that communication work so you can both get the most out of one another?
Usually I say things like, more blue, more blue. No, actually, so my first degree was in history of art, and so we did the whole history of pigments under the microscope. So I have the continuum of the history of pigments in my mind, and we've actually made them. You would be surprised how things haven't changed dramatically for the pigment world until now. So this is where I communicate with the quantum scientist to bridge the gap between just grinding a stone and adding a binder and taking quantum dots and adding the binder. So yeah, and so far it has worked beautifully.
Thank you.
Yeah.
Hi, thanks for a good talk. There's a bunch of scientists and materials people in the room. I guess I'm wondering about photo stability. Quantum dots can be subject to oxygen and moisture poisoning, and I'm wondering how these pigments are being treated. AV, thank you. How these pigments are being treated to avoid wavelength shift and also degradation, efficiency loss in the presence of oxygen.
Right, well, I'm not sure I can actually tell you that. I would be giving away too much, I'm afraid.
But if he invested in the company...
But if you did, then well, I'll think about it, yeah.
Sounds like you like the question, though. Okay, thanks.
Other questions or comments?
Yeah, on that side.
Oh, yes, please.
Hi. As you said, when we add if we add colors when we're painting, we have to use in different way when we do additive. Red and green gives us yellow on a TV, but red and green, when we mix colors, we get brown. Do you think we have to develop new color theory for quantum dots when they become pigments? Like the color space as we use now in displays, would that be suitable for quantum dot pigments, or we have to develop something new?
So I think that's a very good question. I think it will cause a great revolution for artists because it will be completely counterintuitive to how they go about it. I think this is one of the most beautiful things for me to see happen. But yeah, I mean, they would have to use how we have the color theory for light, so additive color theory.
So
but it will be completely counterintuitive to use it with actual pigments.
So the color theory for light would be sufficient, or we have to have a hybrid theory for quantum dots, additive plus subtractive together, a third hybrid theory.
So I think yes, also it will be definitely a hybrid, because I'm sure people will start mixing quantum pigments with conventional pigments. And also, there's also other things to figure out, whether, you know, what happens with combined quantum pigments with themselves, and different chemicals that artists use in any case. So different filters on top, different layers, different varnishes. So there's a lot to be explored. That's why we've just opened this new chapter, and there's a great deal of work ahead of us.
Thank you. Thanks.
Thank you.
The color people are using Mansell diagram. Now you will have to generate a new diagram.
Yes, we would have to generate a new red so that people stop eating bugs.
So I have a question about illumination. You said you can see the blue car in yellow light. I don't think so, because yellow has lower energy than blue. But can you view your paintings in candlelight, for example, or do you have to replace the illumination in homes and art museums and so on?
So the example I used earlier was about conventional pigments. A conventionally painted blue car in an underground parking lot where the lights are usually yellow-orange, your conventional pigment will look, with a combination of the lights, green. With quantum blue, it wouldn't be the case. But whether you could see paintings painted with quantum pigments in candlelight, I guess it would, you know, have to do with what kind of candles we're talking about. Is it, you know, IKEA tea lights or more substantial?
I don't think so.
You don't think so?
No. So
Okay.
maybe the museums will have to replace the lamps in order to view these artworks.
I mean, museums have always have very adjustable light depending on the material in any case, because there's paintings that are very sensitive to light because of their age, and other ones that need more light because of their, you know, theme. So it's not a problem for the museums. This is already, humidity and light is a given for museums.
Okay, thank you.
Mm-hmm.
Thank you so much for such an illuminating talk. As a hobby painter myself who work on displays, this is actually really exciting to see. I'm rather curious, since you listed a number of different applications, what are some of the first applications you're actually trying to tackle with your startup?
Right, so the first applications are artist pigments, cosmetics, and plastics.
Interesting. So when would you expect for me to be able to purchase a tube of these pigments?
Good question. Yeah, I'm not sure exactly, because we're just finishing our first round now, so soon. But yeah, I don't want to give you a date.
Awesome.
Yeah.
Sorry, one last follow-up. Have you actually tried painting with one of these pigments yourself?
I have, yeah. I've actually, the first painting I did was back in Berkeley laboratories, where I did a landscape of a sea at the blue hour. But back then it was a very crude formulation that I had done at Berkeley lab. Now, of course, we are creating way, way, way more sophisticated formulations than that.
And a lot of these, I know traditional pigments can also have heavy metals. Is this something that we can expect your pigment to be environmental friendly and non-toxic?
Well, look, professional artist pigments actually contain cadmium. Red cadmium is a classic, like ultramarine blue, that painters cannot really live without.
Right.
So even though cadmium has been phased out in many other industries, it's even the European Union allowed us to use cadmium in pigments. So for the artist pigments, we will have one red that has cadmium, but for the others will be heavy metal free.
Awesome. Thank you so much.
Thank you.
Other questions? It sounds like that first painting might become very valuable someday.
Yes.
If there are no more questions, maybe we can thank our speaker again.
Thank you.
Great. Thank you very much, Olga, and thank you very much, Nikhil, for your leadership as the first ever keynote chair. I think you're 4 for 4, so I can assume we can rehire you, I hope, for next year. So with that really interesting final keynote, I think we're all set with our speeches for today. I just want to thank everybody and congratulate all the award winners. And please enjoy the rest of lunch and the rest of the conference. So thank you all very much.